children, this is Rupa, chemistry madam. Okay, today we are going to discuss on the topic chemical bond. In the previous chapters, we have learned the periodic table and atomic structure. And in atomic structure, you learn that the atom contains the fundamental particles, which are protons, positive charge, neutrons, neutral, and the negatively charged electrons. And we have learned the different types of atomic models. So finally, what we think, the atom is spherical, in which the center of the atom is spherical with all positive charge and all the mass. I wrote here plus and 0 because the plus indicates protons, the 0 indicates neutrons. So of course we know that the sum of protons and neutrons is a mass number. Okay, and around this spherical nucleus, the electrons are revolving in circular path. The path is circular. Why? Because nucleus is spherical. Okay, and this circular path is called as orbit. Is known as a orbit. Okay, or main energy level, which you have learned already, that the orbit is explained by the principal quantum number. So around the atom, in the atom, around the nucleus, as atomic number increases, everyone knows that atomic number increases, the number of electrons increases. So what happens, as number of electrons increases, the number of shells also increases. So out of 1, 2, 3, 4 like that many, up to the you will have infinite orbits. So every element will have its last electron. Okay, the last electron is present in the last orbit, which is known as a differentiating electron, as you learn this in periodic table. So say for this element, its last orbit is third, 1, 2, 3, third, and its last electron in the third orbit. And the center of nucleus to this last electron is known as atomic radius, which is the first periodic property which you have learned in periodic table. Okay, so as atomic number increases, number of electrons increases, then the last orbit moves away from the nucleus. So thus what happens, the size, atomic size of the element increases. And then generally you have learned that as atomic size increases, the nuclear attraction over the last electron, as distance increases, this attraction on the last electron decreases. So larger the size, lower. Okay, lower is the nuclear charge. So in large atom, the nuclear attraction or the concentration of nucleus on the electron is less. Or you can see here, the attraction of nucleus on this inner electron is more because it is close. At the same time, as it is moving away to the last electron, moving away to the nucleus, the distance increases, the attraction decreases. So in this case, you learn that to remove this outermost electron, you have to break down the attraction between the nucleus and electron, which is known as ionization potential. Okay, it is known as ionization potential. So if the size of the atom is more, the nuclear charge is less. So to break this attraction, the required energy, which is called as ionization potential, which is less. So larger the size of the element or atom, lower is the IP value. At the same time, if you want to remove the electron from the small atom, in small atom the electron is very close, so therefore the attraction on the electron from nucleus is more. So strongly held by nucleus. In this case, the energy required to break attraction between the nucleus and small atom electron is more. So this is what we have learned. And small atoms, okay, the small atoms, you already learned that the small atoms, if it is small atom, okay, small size is there, then in that case the electron is very close to the nucleus. So therefore the nuclear charge over the outermost electron is more. In this case the electron is strongly held by nucleus, so the IP will be high. So these small atom, now avoid these 3 orbits, take just only one. Now it is small atom. So because of the distance between the outermost shell and nucleus in a small atom, the positive charge over the outermost shell is more. So therefore the electron which is present in the last orbit is strongly held. To remove this, more energy is required. Therefore IP value is high. Then these small atoms have tendency to gain electron. If you put a electron in front of small electrons, they readily capture this electron because their outermost shell is very close to the nucleus. And what is coming from nucleus? The positive charge is coming. Okay, so the smaller atoms have a high tendency to get electron. So if it is in non-bonding state, that phenomenon is called as electron affinity. So small atoms have high electron affinity. If the element is in bonded state, so in this case the bonded small atom have a tendency to attract the bond pair of electrons towards itself, and which is known as electronegativity. So see here, this is one atom whose size is so and so. Now I'll take one more atom. This is smaller one. Now these two are in bonding. These two are in bonding. Okay. Now the small atom has more nuclear charge as nucleus is close to the bond pair of electrons. Okay. Bond pair of electrons. So these bond pair of electrons are pulled towards the smaller atom. So thus the tendency, if I take this large atom as A and small atom as B. So here the small atom, due to more nuclear charge, has a tendency to attract the bond pair of electrons towards its side. So this tendency of a small atom to attract the bond pair of electrons towards itself is known as the electronegativity. So the bonded atoms, if they are small, they have high electron negativity. And this large atom, due to large size, its nuclear charge is not much over the bond pair of electrons. So this large atom is moving away. It is losing its electron. So remember, due to movement of this bond pair of electrons towards the smaller atoms, the large atoms get a positive charge partially as the bond is moving in favor. The bond is moving in favor. The bond is moving in favor, that is close to the B small atom. So A large atom is somewhat losing electron, so gets partially positive. At the same time, the small atom is gaining its side electron pair, the bond pair, therefore become partially positive. And wherever you find a molecule in which the bond is moving towards small atom, okay, which is high electronegative, they acquire the partially positive and partially negative charge poles. Such molecules are called as polar molecules, having positive pole and a negative pole. At the same time, these molecules also called as dipolar because two poles are present, a positive pole and a negative pole. And remember, any compound having a molecule such as partially positive and partially negative, they are called polar, and there's a phenomenon. A rule is that a polar substance always dissolves in a polar solvent. So the salt NaCl, common salt, highly soluble in water because the sodium chloride contains Na plus and Cl minus, which is highly polar, and water which contain the H2O formula, and in which you know that the hydrogen electronegativity is 2.1, where oxygen is 3.5. So due to the high electronegativity difference between the oxygen and this hydrogen, the bond pair will move in favor or closer to the oxygen. So from both the side, the oxygen gets electron density, so it gets partially negative from both the side. So say -2 into 2. So from this side plus delta, and other side also plus delta, and on the oxygen 2 times. So here the sodium chloride salt, which is Na plus Cl minus, which is having positive and negative ions, means this is polar. The salt is polar, the water is polar. So the reason for the highly solubility dissolution of salt in water is light dissolves in light. Understand? So in the same way, the alcohols have polar OH bond. Alcohol formula is C2H by OH, that is ethyl alcohol, soluble in water because the water contain OH bond and the alcohol contain OH bond, and in between the OH of both the molecules, intermolecular hydrogen bonding is formed due to both are polar. Okay, so this is what we should know about something about the first basics of elements, about large atom and small atom. Then after that we can go for the chemical bond. Okay, then I will explain what is a bond in next video. Yes, coming to you.